I'd also like to try this with a little bit more difficult problem. So this one's going to take a few more steps, but I think it's worth it to look at it so you can see the process again. So step one, we want to write this in an augmented matrix. So I have 3, 1, 1, 1, 1, 3, 2, 2, 2, line 31, 19, 25. So off to the side, I'm going to write them. This is row 1, this is row 2, and this is row 3. Now remember, I'm going to draw it up here. I'm going to do this in green, that for the diagonal matrix or for the main matrix of this one, we want it to look like this. Oops, yes, that's right. B, E, F. So we want to have the diagonal and everything under the diagonal 0. So when I first look at these, I notice that the second line and the third line both have 1 as their first number. So instead of trying to multiply by 3 or trying to work this one out, maybe I should just switch them. So my first step for this one is number 1 is I'm going to switch row 1 with row 2. And I'm going to do that right here. So now I have 1, 1, 2, 19, and I also have 3, 1, 2, 31, because I've switched rows 1 and 2, and 1, 3, 2, 25. So that's fantastic. Notice that I have 1 in the correct position, and I have 1 in the correct position here. So now I want the 3 and the 1 below A1 to be 0. So I want this 3 to be a 0. So the only way that I could get 3, and I'm going to write out my step underneath here. So for the second step, we want this row to be 3 using the row above it. So I can multiply row 1 by -3, then I would have -3, and I could add it to row 2. So we're going to do this in a step off to the side, and then we'll add it in. So for this new second line, we would have row 1, so that's 1 times -3 plus row 2. Then we would have row 1 times -3 plus row 2. Then we'd have 1 times row 1 plus row 2. Oops, I'm sorry, I made a mistake. We'd have 1 times -3 plus row 2. Well, that's not 1, it's 2. There is the mistake. And last but not least, we'd have 19 times -3 plus 31. So now I have 1, 1, 2, and 19. Then I'm going to simplify these. 1 times -3 plus 3 is 0. -1 times 1 times -3 is -3 plus 1 is -2. And then I have 2 times -3, that's -6, plus 2 is -4. And -19 times -3 plus 31 is -26. So now I want to look at this again. Oh, we still need the third row, 3, 2, and 25. Remember the object is we want this diagonal to be 1. So the next number I need to tackle is this number, and it's -2. So what can I do to this line to make this -2 be 1? Well, the answer is I can multiply row 2 by -1/2. So now, when I multiply that through, we're not doing anything to the top line. We're not doing anything to the bottom line. But for the middle line, we're going to multiply everything by -1/2. So 0 times -1/2 is 0. -1/2 times 2 is 1. Negative 1/2 times negative 4 gives me positive 2. And negative 26 times negative 1/2 is positive 13. Well, now we're making some progress. So the next thing we need to do is we need to decide if we want to get rid of the 0 here or if we want to make this a 1 here. So I'm going to move this to the next slide right quick so we have some extra room. Right, so this is the step that we're on. And so now we want to look at the next step. Right, so we'd like to take this 1 and make it 0. So if we want to make this 1 0, I can start by using that first line again. So the next thing that I'm going to do, I don't know what step we're on, we'll just call it step 4. I think we're on step 4. So I'm going to look at the first row and decide what I need to do to the first row to make the second row equal 0. So if I do row 1 times negative 1 and add it to row 3, this should make the bottom row 0 for the first number. So let's go ahead and do this step. So we have row 1, which is 1, times negative 1 plus row 3, so plus 1. The next one we have 1 times negative 1 plus 3. Then we have 2 times negative 1 plus 2. And then we have 19 times negative 1 plus 25. So now we want to go ahead and create our new matrix using this step. So we're going to get the first row and the second row are going to stay the same now. And we have the steps for the third row. So we have negative 1 plus 1 is 0. We have negative 1 plus 3 is positive 2. We have negative 2 plus 2 is 0. And we have 19, negative 19 plus 25 is 6. All right, so the next step is that we want to make this number, let's change colors so we can see again. We want to make this number be a 0 as well. So the only way I'm going to get this number to be 0 is to use one of the lines above it. Well, I don't want to use the top line because I have a 1 and a 1, so it might be more beneficial to use the second row. So this time I want to decide what I want to do to the second row that when I add it to the third row, it will make the 2 become a 0. So if I multiply row 2 by negative 2 and then add row 3, I should get my fifth step. So we're going to do that off to the right here. So we have row 2, so that's this one, 0 times negative 2 plus row 3, which is 0, which gives me 0. Then I'm going to do 1 times negative 2 plus 2, which gives me 0. Then I'm going to do 2 times negative 2 plus 0, which gives me negative 4. And I'm also going to do 13 times negative 2 plus 6, which gives me negative 20. Now I have a new third row. So my third row is now, well, let's fix the first two rows. Nothing has changed on the first two rows. 0, 1, 2, and 13. And my new row is 0, 0, negative 4, and negative 20. So I'm going to move this to the next slide. So now I have this, and now the last thing I need to do to make sure this is complete is I need to have a 1 for this number on my diagonal. All of the numbers on the bottom are 0, so those are complete. So again, the last thing I need to do is make sure this negative 4 is now a 1. Well, this is one of the easier steps, thankfully, is since I just want to change this number and these two numbers are already 0, I can just multiply by its inverse. So I'm going to multiply row 3 times negative 1/4. So now I get 1, 0, 1, 1, 2, 2, 19, 13, and for row 3. So we're going to multiply everything by negative 4. 0 times negative 1/4 is 0. 0 times negative 1/4 is 0. Negative 4 times negative 1/4 is positive 1. And negative 20 times negative 1/4 is positive 5. We are finally at the part where we can do our answer. And let's show you why again. Remember, we wanted the diagonal to all be 1s, and we want everything underneath it to be 0. Now we can see that we have x plus y plus 2 equals 19. We have y plus 2 equals 13. And we have, oops, that's 2z and 2z, my mistake. And z equals 5. So let's write our answer out. We're looking for x equals, y equals, and z equals. We know z equals 5. We're going to substitute z into the second equation. So I'm going to change colors. We have y plus 2 times 5 equals 13. So that's 10. So 10, we're going to subtract 10. That gives me y is 3. And now we have y and z, so we can solve the top equation. So we have, let's do it in green, x plus 3 plus 2 times 5 equals 19. So we have 10 plus 3 is 13, 19 on the other side, so when we subtract, we're left with 5. Oops, I'm sorry, 6. So we have x equals 6. And now we have successfully completed a Gaussian reduction. These take our Gaussian elimination. These take a lot of steps, but they always come up with the correct answer. So again, this is our solution to this problem.